Hello, I'm going to be showing you how to complete the Climate Solutions Simulator Lab. First, you're going to need to open up our physics launchpad or go to the links in Google Classroom. So the first thing that you're going to need to do is to view the various solutions that your classmates suggested from our activity last week. You're going to pick two of these that you're going to try to simulate using the En-ROADS simulator. Before you do that, however, you're going to be meeting with your team, and you'll start by filling out the group collaboration reflection sheet. On this, you put your name, put your group members' names, and this is a place for you to record or to set some goals for you and your team. As you work together, you need to make sure that you are respectful, equitable, that you commit to your community, and that you are pushing your science thinking forward. So I want you to work with your team to come up with some things that you guys are all going to do to achieve that. What are you going to do to be respectful and equitable? What are you going to do to push your science thinking forward? Put that down as a group, and then make a personal goal for what you want to achieve while you're working together as a team. After you've done that, you can then open up the assignment, the Climate Solutions Simulator Lab, which looks like this. Make sure to put your own name there. The first thing that you're going to do is choose two actions or solutions that people or governments can take to reduce the future impacts of climate change. For me, I really like the idea of using fewer cars or biking more. I also like the idea of not burning coal to produce electricity. So the next question, why did you and your group decide to focus on these two solutions? That's where you can elaborate. You can talk about whatever you want. Why did you choose those things? I really like bikes. I think they're really fun. I think cars pollute a lot. Um, I think burning fossil fuels, burning coal in big factories to produce electricity. I think there are a lot of better ways to produce electricity than producing lots of amounts of carbon dioxide from burning coal. Like, you can type all that into this section here. Next, you're then going to go to the En-ROADS Climate Interactive Simulator, which looks like this. And there are a lot of different parts of this. So the next step on the assignment is to describe the specific parts of the simulator that you're going to use to model your solutions. In this video, I'm mostly going to be talking about the biking more, just to make this video go a little faster. And when I look at all these different options, I can think of a lot of things like maybe oil, because I know oil is what's used to produce gasoline. Or what about transportation? If we're going to be using fewer cars, maybe that has to do with transportation. So maybe I can open up one of these and I can read transportation energy efficiencies, the increases or decreases in energy efficiencies of vehicles, shipping, air travel, transportation systems. Okay. Energy efficiency includes things like hybrid cars, expanding public transit, and ways that people can get around using less energy. Ah, there it is. That is what I'm talking about when I'm talking about biking more. So this is the one that I want to use. So I'd go back over here and I would type in transportation efficiencies, blah, 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 for that one. I would do the same thing for figuring out which one I want to talk about for not burning coal. And then, why do you feel those parts of the simulators are the best way to model your specific solution? For that, I would talk specifically about how this one describes that it's looking at ways people can get around using less energy, whether that's for personal vehicles, shipping, air travel, or transportation systems. I could talk about all of that in this section right down here. Okay, now we need to move on. So once we have that background, we can actually start to collect some data. So first thing, data and methods. I need to write out what my independent variable and dependent variable are, including the units. So for my independent variable, again, that would be the transport energy efficiency. So I would type that in, transport energy efficiencies, and it says include the units. So in my simulator, it talks specifically about the percent of change per year. So I'd go back and I would type in. So for our dependent variable, In that, if I'm going to be adjusting this and looking at what changes, the biggest thing that I notice that changes is right over here, and it's the big thing that we talk about when we talk about climate change, is the temperature. And you could do in Celsius or Fahrenheit. I'm going to choose Celsius since it's the big one and it's easier to read as I change these. Temperature by 2100, sorry. And again, I want to do units, so I'll say Celsius. And I could read more if I wanted to like look into this a little bit more. I could read about how the dotted lines reflect the goals of the Paris Climate Agreement to 2 degrees and our aim of lowering it to 1.5. So I could describe how like, the goal is to get it below this 1.5 level. But by law, by the Paris Agreement, we have to keep our temperatures below 2 degrees change, which looks like right now, doing our business as usual scenario, that'll happen in the year 2043. So, a good 23 years. We have like 23 years before we cross that mark and things are not going so good. So will we be able to drop our temperature below that by the end of the century? We'll find out. So if I'm going to identify which various transportation energy efficiencies I'm going to choose, that's over here, this percent year. So what is my range that the simulator will go from? I can go from -1 all the way up to 5. So I'm just going to make that really simple on me. I'm going to go -1, and then I'll do 0, 1, 2, 3, 4, 5. Pretty simple. So now I just have to go over here and I can test those. So at -1, the temperature is 4.3. So I'll type that in, 4.3. Go down and then go to the next one, go to 0. And the answer is 4.1. And then go to 1, and I'll speed this up. All right, so now I have my data, and I've been able to see how the transportation energy efficiency affects the temperature change. And it took us from 4.3 degrees of change down to 3.9, which isn't great, but okay. I guess, that's just what the simulator says. So let's next graph this. So in order to, first we would want to graph this. I can title it the effect of transport energy efficiency on temperature by 2100. I'm just like copying the effect of this on this. Okay, now to edit the graph, I can click on this and go down to edit. I can change my dependent and independent variables. So again, I'm just going to copy that same thing. So, and you can change the dependent variable to be the same thing that you had there. Okay, so before I graph this, I have to look at my numbers. So the independent variable goes from -1 to 5. So I'm going to go back in and edit. And what I notice here is that my numbers here don't match -1 to 5. So I'm going to change it. -1, tab 0, tab 1, tab 2, tab 3, tab 4, tab 5. Okay, and then the same thing for my temperature change. The range that was already in here was 0 to 6, and I don't need that. I only need from 4.3 to 3.9. So I'm going to adjust this. I'm 3.3, 3.6, 3.9, 4.2, 4.5. So they're just going up by 0.3 every time. And now I can just go in and plot my numbers. So I look in my graph here, and I can go in and just start typing in those numbers. So I would use the this little scribble tool. Actually, I'm going to use the shape tool. I'm going to put little dots. So at -1, it was 4.3. So I'm going to estimate that's right about there. I'm going to put in a dot right there, and then go to another shape. And then at 0, it was all right. So I have my dots put out there, and I could even make a line that connects them. So let's do, all right, so now I have a pretty good graph. I'll hit save and closed. So I have this graph. All right, so um, I have collected my data, I've made my graph, I see what effect it has. Now I can go on to the next step, which is actually just sort of a reflection of some of the other things. So this next section here, what initial settings did you use or adjust, but kept the same while adjusting your independent variable? So I'm going to go back to my climate simulator. So in this simulator, when I was adjusting my energy efficiency numbers, I kept everything else pretty much the same. So I can say energy supply, land use, and carbon removal, all of those stayed constant. Land and industrial. So like you just type in what did you keep the same in each of those, because it might be that you actually are testing multiple things. For example, if I was interested in uh, energy efficiency using more bikes, maybe at the same time I was already interested in um, removing oil, saying that oil was not a thing. We did not use oil at all anymore in our transportation system. And then when I adjusted the energy efficiencies, I would have kept oil over there the same, but I would have collected the data just for these numbers over here. And you can see that if I did that, the temperature would be late. It would be 3.8, whereas with oil, we only got to 3.9. So we could have done better if we had different settings set up. So you're welcome to like change any of these other uh, uh, variables, but just describe which ones did you start with right at the beginning. Okay. The next thing that you can do is record notes of things you observe that might be important when describing this variable. So when I was adjusting this, I was also taking notes and making some observations about some things that changed. I mean, one of them was this idea that like after getting above 3%, the temperature didn't really seem to have an effect. It sort of dropped out down here and stopped getting any better. Our simulation stopped, we stopped having any changes, that the temperature stayed the same. Maybe some other things that I might want to note is like if I'm going back and forth over here, like with all of this, if I was looking at some of like these other graphs, this red one I notice, what is red? Red is oil. So I would want to write that oil had the biggest changes in the coal also decreased. That's an interesting observation. You can even go into other things. Over here on a lot of these, you can drop down and look at various other observations. I don't know, I'm going to pick some other graph. More observations, the better your science. Okay. Next task is to write a summary of your results. So here's where you get to summarize this graph and any of the notes that you made. That was for your first solution. You'd then go back and to your ideas. So that was like using biking more, using fewer cars, and then you'd go to your second one, which is like burning coal or whatever other thing, and you do the same process again for solution number 2. I'm not going to show you because it's the same thing that I just described. Once you get both of those done, you can then move on to your conclusion. The conclusion is the place where you are putting all of your ideas together and also trying to explain why those ideas occur. So the main question that you're answering is which solution to climate change is better? You're comparing your solution number 2 to your solution number 1. And you just answer that question as your claim. I think solution number 1 was better. Reducing the use of cars is better, whatever it is. Your evidence for that claim is a comparison and contrast of your two solutions. So you might talk about the specific like idea of how this one only decreased from 4.3 to 3.9. So that's a 0.4 degrees Celsius change. So using bikes decreases the temperature by 0.4 degrees, whereas coal, which is our solution 2 or whatever idea it is that you have, decrease the carbon or the temperature by 2 degrees. You would write that into the evidence section down here. Your evidence can also include information from the simulator like time, cost, or other things. So again, down here, you might have to change how much money is spent. Like, it might cost $100 per BOE. Now, what is BOE? You'd have to look in here. Dollars per barrel of oil. So that's the cost of a barrel of oil. Does it cost $100? Are you decreasing the cost to be negative $15? What impact that it has? So you can include all that other information in this section. Then you get to your reasoning. So there are a number of questions. What scientific concepts help you to explain your evidence, or what your evidence is showing? What assumptions are you making about humans, the climate, or how the simulator works? So again, you can use those drop-down menus in the simulator. Like use some of these drop-down menus here. You can open these up. You can use these extra graphs or informations to describe what each of these things are showing. Any of these drop-down menus here actually have some information that you can use. And essentially, you're just trying to explain why does that evidence have this impact. So why, if we go back up to our example here, why does making the transport energy more efficient, why does it decrease the temperature? And that's where you could talk about the specific climate change stuff, where, if driving cars produces carbon dioxide traps traps heat because it's a greenhouse gas, and that heat is what is changing the temperature. So if we produce fewer greenhouse gases by making our cars more efficient, there'll be fewer greenhouse gases and less heat will be trapped, which means the temperature gets colder. That science background is what you're describing down here in your reasoning. You can also talk about any assumptions that you're making, and in the En-ROADS simulator, up here in the simulator, you can actually look at that and talk about the different assumptions that are being made. So you can look at this assumptions section and you can open these up. So if we talk about fossil fuel utilization, you can set some of these assumptions. What do these mean? How sensitive is the climate? If you adjust any of these things over here, that's what you can talk about. And then what results were surprising? What other things might need to be considered? Again, when I did this initial one, I was actually sort of surprised that increasing beyond 3 degrees doesn't really do anything for the climate. Or just the idea that we could make this energy really efficient and we only make that tiny amount of difference. I find that surprising. And what other things might need to be considered? Well, one of the things is that this simulator is assuming that all we're doing, if we start this one back up here, that all we're doing is making this one energy efficiency better. But maybe the actual solutions will have to, do this and do that, and also increase bioenergy, and also make sure we have more, more forests, more carbon removal, and maybe the price of carbon goes way up, and maybe we do a lot better with renewable energy, and we use more electric cars, and we have good economic growth, and we increase the amount of all these other things. And at least okay, now we're getting a lot closer to our 2 degrees of change, but even all of these changes combined aren't the best. So you might want to consider what are some different suggestions about how multiple solutions work together to have a bigger impact. And you can write in what you suggest would be the best option. And that's your conclusion section. Once you've done that, every group member needs to submit their own document for this simulator lab, and you also need to go to the group collaboration reflection page, scroll down, do this reflection after the lab. Did your group finish the task? Yes or no? Did you meet your own personal goal? This one over here. Did all the group members follow the group norms? Why or why not? What can you do in the future to help your peers learn? So you fill this out as a reflection on how well you were able to work with your group, and make sure you submit that as well. And also, I would, the last thing I can say is that if you do have any questions, be sure to send me an email, let me know, and I will help you out as best I can. I look forward to seeing all of your results.